Here is an equation that should not work. King minus man plus woman. These are words. You cannot do algebra on words. But in 2013, researchers at Google did exactly that. And the answer came back, queen. This is not a metaphor. The machine really computes it. And it is the reason AI understands you at all.
Episode 4, Embeddings, How a Machine Turns Words into Numbers and Numbers into Meaning. A computer has never seen a word. It sees numbers. That is all it can see. So the word cat arrives as character codes, 99, 97, 116. And those numbers are useless. Car starts with the same letters and means nothing similar. Kitten shares almost none and means almost the same thing. For decades, the standard fix was a dictionary trick. 400,000 words, 400,000 slots, one light per word. But in that scheme, every word is exactly as far from every other. Cat is as far from dog as it is from carburetor. Meaning, 0. The Way Out was written down in 1957, before AI existed. The linguist John Rupert Firth, "You shall know a word by the company it keeps." You do not need a definition of cat. You need to notice which words appear around it. Purr, fur, vet, whiskers. Count those neighbors across billions of sentences, and something remarkable happens. Words that mean similar things end up with similar counts.
Turn those counts into coordinates, and every word becomes a point in space. These are the actual 50 numbers for cat, learned from 6 billion words of text. No human chose them. And now, meaning is measurable. Cat and dog, 0.92, nearly parallel. Cat and kitten, 0.64. Cat and car, 0.36. Cat and carburetor, below 0. In fact, out of all 400,000 words, cat's single nearest neighbor is dog. The dictionary trick gave every word a lonely slot. This space gives every word a neighborhood.
One more thing about that map. We drew it flat on a page, but the space is not flat. Here are the same words again with 3 coordinates instead of 2. Watch what happens when it turns. The animals hold together. The countries hold together. The royal words sit off on their own, in their own corner. These are not clusters anybody drew. They are clusters the counting produced. And even this is only a shadow. The real space has 50 axes, a direction for tense, a direction for gender, a direction for how formal a word is, and 40-odd more that nobody has ever named. 3 is simply all your eyes can hold.
We keep saying point. Let's be precise. A list of numbers like this is called a vector, and a vector is 2 things at once. It is the numbers, and it is an arrow. Start at 0, go 0.9 along the first axis, then 0.08 down the second. The numbers are the instructions. The arrow is the picture. They are the same object. Here is cat, drawn in 2 of its 50 coordinates. Here is dog, nearly the same arrow, nearly the same direction. And here is car, pointing the other way entirely. That is what the cosine was measuring all along, not how far apart the words sit, which way they point. Arrows can do arithmetic, and it is simpler than it sounds. To get from man to woman, you follow this arrow, the difference between the 2 vectors. Subtracting gives you the step from one to the other. Now take that exact step and start it at king instead. You land here, and here is where queen actually sits. Close, the same corner of the space, but not the same point. Because we are only drawing 2 of the 50 coordinates. Restore the other 48, and the landing moves on to queen. That is the calculation we are about to run.
And if meaning is geometry, directions mean something. Take king. Minus means exactly what it says. Subtract each number. King begins 0.51. Man begins minus 0.09. Subtract, add woman, coordinate by coordinate, all 50. You get a brand new point, a point that is no word at all. So we searched all 400,000 words for the one nearest to it. We ran this. The answer, queen, at cosine 0.85. The direction from man to woman is the same direction as from king to queen. This space learned gender as a direction. Nobody programmed that. It fell out of counting.
Here is the whole thing in NumPy. Line 1, load the vectors. 400,000 rows, 50 columns. Line 2, divide every row by its own length, so each word becomes a unit arrow, and comparing two directions is just a dot product. Line 3, the arithmetic you just watched, king minus man plus woman. Line 4, multiply that single arrow against the entire matrix. That one operation computes 400,000 cosines at once. Line 5, rule out the three words we started from. Line 6, take the largest, run it, and the machine prints queen 0.852. 9 lines of code, and a space that learned what a queen is by counting words.
It is not one trick. Paris minus France plus Japan, Tokyo, 0.92, an even stronger match than queen. Walking minus walk plus swim, swimming. And look at the country arrows. 6 different pairs, 6 different parts of the world, all pointing the same way. Their directions agree to a cosine of 0.85. Verb tense is a direction. Plural is a direction. The space did not memorize these facts. It organized meaning along axes it invented itself.
This is not a toy. Inside a GPT-class model, every one of 50,257 tokens becomes a vector with 12,288 coordinates. Before anything else happens, before any reasoning, any answer, your words become points in a space where meaning has a shape. Embeddings are the front door of every AI you have ever talked to.
But this space has a crack in it. Bank gets 1 point, so the river bank and the savings bank collapse into the same meaning. A frozen map cannot see context. A word's true meaning depends on its sentence, on the exact company it keeps right now. Teaching machines that took one idea. In 2017, 8 researchers called it attention, and it changed everything. That is the next episode.